Hello, everyone. My name is Lauren Sebastian, and I'm here with the product team at SpidaCalc. I joined SpidaCalc just over a year ago now, and before that, spent several years in industry working as an electrical distribution, transmission, and generation engineer. Today, we're going to look at how calc can be utilized to aid in asset modeling and review from a single project to larger asset ownership review as well. We'll take a look at modeling both new and existing assets, reviewing the output analysis that SpidaCalc has to offer, and how connected pole lines can be leveraged within both SpidaCalc and Spida Studio. Just to recap who SpidaCalc is, just in case, we are a small team out of Columbus, Ohio, supporting a growing user base primarily within US and Canada, but internationally as well. With our acquisition by Bentley Systems in June of 2021, we are continuing our commitment to help build a better grid by delivering critical asset intelligence that is driving better decisions, resulting in a stronger and more intelligent grid. Last webinar, we discussed the portfolio within Spida software as a whole, showing how Calc, Silk, and Studio all interact to address unique issues while working together to streamline solutions. We also touched on the life cycle of overhead assets and how Spida software products play a role within each stage. Today, we're going to focus more specifically on how SpidaCalc can be utilized within these phases to simplify the engineering and design process, as well as the overall asset lifecycle. For now, I'm going to switch over to a screen share. So give me just a minute to share my screen. Okay, so SpidaCalc is a desktop application used to model and analyze overhead pole lines. On the back end, it utilizes a robust geometric nonlinear engine to provide accurate results based on real-world construction. On the front end, it has a very user-friendly, easy-to-use graphical interface designed to make it simple for users to create models, review results, and update or adjust as required. So let's go ahead and get into SpidaCalc and run through some common scenarios. SpidaCalc allows users to start projects a number of different ways depending on your desired workflow. We can start a project from a CSV, for instance. So if I come up, I can start a new project from a CSV. The CSV file is going to include information on your pole height and class, lat long for location, as well as species to populate the locations within our project. Before I get too far into this project, I'll just go ahead and give a high-level overview of our user interface. Calc has a number of different views, which gives users flexibility to add or remove from their workspace. I generally like this project panel to appear, so I can come in, choose my project panel, and dock that into my view. We also are able to pop out views and move them to different screens, able to resize them as well. And if I want to come back and dock that into my view, I'm able to do that. You can always have preset reviews. So if something gets screwed up and you don't like how it looks anymore, you can always come back and resave your views to default. You can also preset your views so that if you come up with a custom view that isn't included in Calc by default, you can come, save your workspace, give it a name, and it will appear in this top list here. So this is where I have my Lauren design, where I have my project panel docked in my workspace. Okay, so let's go ahead and model some poles within Calc utilizing some of our features. To start, I'm going to want to multi-select some of my poles so I can frame these poles in bulk. So in my map view, I'm going to multi-select my poles in this view until I have selected the run that I want to frame. Calc utilizes this concept of framing assemblies, which allows you to save configurations and apply them to your pole. So in this case, I have a tangent cross arm with 3 phases and a neutral. I can go ahead, change my wires that I want to apply, update my ruling span tensions if applicable, utilizing my map view estimated ruling span in the process. And once I'm happy with my selection, I can simply come and drag into my map view. We'll see in the 3D view here that it has now gone ahead and framed multiple poles. And I can continue adding wires to my selection without having to repeat clicking my poles. So let's say I want to add some telecommunication bundles to this line. I can use the embedded calc bundler functionality to create a custom communication bundle. This information is pre-populated in my client file, and I can simply come in, click what number of fiber cables I would like to add to my messenger. Calc will automatically calculate the diameter and weight per length based on those fiber properties, and then it will appear in my selection list. When I drag this into my map view, I'm going to have a couple different options to place this cable. I can either do it from a distance to other communication or power cables already on my pole, or simply a ground up height. For this one, I'll just go ahead and set it at that 7 meters above ground. And if I wanted to add a second cable to my pole, this time around, maybe I want to underbuild the existing communication. These options are now ungrayed out as they weren't previously available because I didn't have a communication on my pole. So I'll just put that 1 foot below and hit OK. Now in my view, we can see our pole line extend through the project. But one of the other things we want to consider is adjacent structures. So on my first pole here, in the real world, potentially it continues an extra span. I don't necessarily want to model that adjacent pole, but I need to include those wires for our loading information for our first pole. So Calc has a very handy feature to accomplish this pretty quickly. I can come and extend my span as I would like. I can have all those wires get copied into an adjacent span by simply clicking and applying to my project. I'm going to go ahead and do that on this span down to the south as well. And if I didn't want all the wires to extend, I simply could come and select whichever wires I wanted in this view, say the communications didn't extend, and do the same concept. This can become a very fast way to ensure the full picture is being modeled accurately within the software. In the assemblies I just mentioned, they are defined by these blue puzzle pieces that appear in your graphic views. They can be saved with support locations. In my component panel to the right here, we can see these guide attachment points. These are predefined locations for if I needed a support assembly to be applied. So for instance, if I come back into my assemblies and I have my assembly selected, I can simply drag and those attachment heights are going to default snap to the preset information. Another way we can aid users to create field accurate models is through our photo heights tool. Down here, I can turn on my assign photos feature, and I can come and assign a photo to my location. This is going to default to having a photo heights tool enabled. There are 2 different calibration modes. For the first one, I'll select pole height. So this is assuming that our pole height is a known entity. And I can zoom in on this so that I can accurately try and set the ground and pole top of my pole. And from here, as I select individual components, I can drag in this photo tool to set the height accordingly on my model. This can become a convenient way to get an estimation of what I have in the field and quickly tweak preset framings that might not be exact in the field. The other option that exists is a known dimension. Say I went out to the field and I actually measured that my communication was at a certain height. Just maybe say that it was at 7 meters. I can go ahead and redefine this leader here to that 7 meters. And as I select these items, they will drag and change as well based on that known dimension. So 2 different methods to utilize this tool depending on what information you have on hand. So I'll just head back to my map view and run through a couple other things that we can tweak to get this model finalized. In this instance, I have this additional tap span, so I'm going to utilize that same functionality to multi-select my additional framings and come back, and this time maybe it's simply a single phase tap on our pole. When I go and drag this, I have preset information in these assemblies to handle underbuild information. So I'm going to want to drop my neutral, say it's a meter. It's going to automatically place that assembly the required distance below my existing tangent framing and relocate the neutrals as required. Now, as we can see here, I added a tangent framing. However, this is going to be a dead end pole. So Calc has embedded functionality to help deal with quickly changing assemblies so that you can apply the most standard one in bulk to your poles, but come back and change those outliers. So all I have to do is select my assembly, come over and update to my new desired framing. I can complete this on as many poles as I would like with just a simple click of the button. And to finalize our model, I'm going to go ahead and apply our guying. We can see once again, we have some preset attachment points. So I'm going to go ahead and apply those to my pole. So in just a matter of minutes, we've been able to model our poles given existing field information and photos to create an accurate field representation. Before we go ahead and model these poles, I'm going to do one last piece, which is applying a damage. So SpidaCalc does do a strength analysis check based on information provided. Let's say I'm up in Canada, so we have snow. This pole got hit by a snowplow. I'm able to select a slice, drag that into my graphic views, and apply the required information that I may have measured from the field. So we can see that icon appear in my graphic view, and now it's in my profile view as well. Now, when I run these analysis, I will see a strength check applied and understand how that slice is impacting my model. When your client file is set up, it is going to have different analysis that you can apply based on your individual scenarios. You can remove, update, or change as required and apply that throughout your project. Once we're ready to get an output analysis results, we can do this by one of 2 ways. We can either click this green button here to analyze our project locally. This is going to run your models in sequence, and it's going to lock down your project. The other option we can do is send this up to the cloud. When I do that, it's going to send up to the cloud. We can see up here, but I can still edit and function in my software. So as those analysis get sent back down, I can review them. My software isn't locked down, so I can send one street up to the cloud, maybe model the other street, and that way you can still be active in the software while you're waiting for your results to return. The other thing the cloud does is split out your analysis into multiple different servers. So you will notice if you send just one single poll with one single analysis up to the cloud, it will take a similar amount of time as if you sent 100 because it is going to split those out based on the available servers. And we can see some of these results are starting to populate back. And so I can go ahead and take a look at our analysis. So here I have applied 4 different cases to my polls. This might not be your typical scenario. I'll go ahead and make these bigger so it's easier to see. So in our summary tab, we're going to have a high-level overview of the percentage of each component. Here on this poll, we'll see we don't have any strength information. But if I go back to that poll that we applied the damage to, we'll see that we do have a populated piece of information here. The other thing we'll notice is in this one case, I have included the NESC medium, and I've also applied the strength factor to the poll. So that's why we'll notice here a different inner percentages, depending on if you want that reduction in strength applied to your loading. As we go deeper into the analysis results, we're going to have much more information available for you so you can help determine what might be wrong with your polls or just review the output. So the same summaries exist in the detailed components. You can have access to the full forces and reactions, as well as the ground line reaction forces of your poll. You can keep getting individual height information for the stress, shear, moment, and deflection for each distance along your pole, and a full radar wind chart based on your load settings. So if you've done a 10-degree wind sweep, then that will be what appears here. If you do 1 degree, you will have details every single degree around your pole. This information is also viewable in our graphic analysis view. You can come and turn on and off the same charts viewable in the details in your graphic views as well, including your load, forces, and wind charts. So in this case, I've modeled my polls. Maybe I'm happy with everything the way it is, but I want to save this for future. So this is where Spida Studio links directly into SpidaCalc to allow us to save these poll loading models and share them throughout our utility. What I can do is just come up here into our little cloud icons in our toolbar. And I don't have these polls already made into Studio, so I'm going to go ahead and create a new project. And then it's going to ask me how I would like this to flow in my Studio. So in this case, I give this project a name. I'm going to assign a workflow. We'll do a little more detail on how workflows exist in Studio in a later webinar. But for now, I'm going to go ahead and say that the measure design is the one I want to send, as that's all I have in my project. These are all going to be created as new stations, and I'm going to hit create. And we can see it's successfully saved to my Spida Studio. So what might that look like in Studio? Here I have the manager view, and you can see that those locations quickly just popped up into my Studio map. And as I click these polls, we can see the information. We can see that the poll is passing and all of the polls have been stored, as well as their results. So I can quickly view the same results that I had in SpidaCalc in our online system, complete with all of the details that we displayed in the software. Okay, so now we've shown how we can create a project, save it into Studio so that it can be used for later. Now let's see what happens if I already have that information in Spida Studio and I want to make an edit or tweak to that design. It works very similar to starting a new project from CSV. Instead, I'm going to open a project from Studio. I can do it in this project menu, or I can use our icon in the toolbar. All I have to do is select which project I want to view. By default, this list is going to show the projects that are active to my profile. If there are existing projects or closed projects that aren't active, you can always do a project search and it will pull up everything within your system. But for this one, I'm just going to go ahead and select this one to open. and it's going to download that information from Spida Studio into my instance of Spida Calc. Okay, so I've pulled down these pole models. I can see off the start that there's something failing, so I might want to make some updates. There's a number of different ways that Calc allows users to track updates. So right now, I just have a measured design. I can test updates in a draft layer. I can create as many of these draft layers as I would like. And you can also rename them by simply double-clicking in to change the name. Alternatively, if I know I'm doing an update to our entire system, so in this case, say, we're doing a system improvement and I want to change my conductor from a 3-out ACSR to a 356, I want to track that through potentially a design layer. So I can come and I'll create a new design layer, which is going to clone my measured design into a recommended for every single location that has a measured design. So for starters, maybe let's take a quick look at what is causing this pole to fail. It's failing under our GO95 load case. The strength factor is too low. So there are obviously a number of different ways we could go about looking to save or improve this pole. For this example, I'm just going to go ahead and change our pole height and class. So we can do that by one of two ways: coming into our components, finding a new pole and dragging that in, or alternatively, we can come into the component properties on the right, and I can use the search tool to find the pole I'm looking for, select it, and then it's going to ask me how I want to handle the height difference. In this case, I'll just go ahead, keep the power to based on the top of the pole, but I'll keep the communications relative to ground, and it's going to reframe that pole for me. So I mentioned that maybe we want to do a capital improvement project and change our conductors. So this is where the concept of a connected pole design will come in handy. All I have to do is select the conductors that I would like to update. So I bulk selected in my side view, but when I look in my map view, I can see where all of these wires are highlighted in the span. These wires are connected throughout this design, so I only need to change this once, and it is going to apply to all 3 wires throughout every single pole that has been highlighted. So if I come up here, I change this to, say, a 336. We're going to see our analysis for those poles are no longer current because it has changed that wire throughout. So as I click throughout my new poles, that has been changed. So this is a fast way that you can either apply an additional communication, change wires to poles that already exist within your model. Let's say I do want to add a second communication to this project. I can come, do what we did previously, multi-select my poles, and add a quick bundle into my pole line. Once again, I'll just place this just below my pole or my existing communication. Now we can go ahead and I covered how to add support assemblies. In this case, I just added a wire. There's no predefined guy attachment point. We can always come and add individual guy wires to our pole. If I select this pole, I can come and basically hover my cursor over the other wire endpoint here, and it is going to default to snap to the highest owner of that type. So in this case, we have 2, so it's not going to default to the dead end. It is going to default to the top owner, but that can be a fast way to apply non-support assemblies to a structure. And I'll just go ahead and in this one, maybe I'll just anchor share instead of adding their own anchor. So once again, if I'm happy with these upgrades, I'll go ahead and send these to the cloud to be analyzed. Maybe I want to confirm that the analysis settings are what I would like. And so I can apply those to all of the poles and go ahead and run that project. As these polls run, once again, they will come back down from the server and we can see the updates. And for the interest of time, because there are 74 different ones, I'm just going to go ahead and remove a couple analysis from our settings, select one, and I'll just run this locally so we can see that populate a little bit faster. And when we run this locally, we do get this now accurate loading bar. It's going to show you how many analysis are running and what design you're on. And you can use the cancel button at any time if you wanted to move out of it. So once again, we can review our analysis. If we are happy with the design, we can go ahead and maybe make some tweaks. In this case, I probably should add a down guy for our communication as it's failing. So I'll go ahead and add another support for our telecommunication. I'll utilize the bisector feature this time instead of the dead end, so it will default into the bisector of our previous and next pole lines. And I'll go ahead and run that individual location. All right. So now that we have all of our poles in this lead analyzed and we are potentially happy with them, what we want to do is save this back into our studio environment. So same way we did before, I'm going to hit that upload button, but this time I'm going to update an existing project. So this time I will actually want to use the recommended design, and I'm not going to necessarily advance the status. Depending on your workflow, you can advance the status to another setting, but if you don't want to, you don't have to. It will still update your designs within Studio, so this is dependent on your workflow. But I'll go ahead and hit update, and it should send my designs to Studio. All right, so we can see that that was successful. It has saved into Studio. So if I come back to my Manager tab in Studio, and I'll just go ahead and refresh. If I find these polls, I'll say select this poll here. We can see that that's the project name that I had used, and it's going to be updated with my additional information. I can click open once again and see the updated results of the polls. Same way I could before. Here we can probably see on my detailed inputs that this 336 has in fact been changed, so that update has been saved. And we can see that this is now the recommended design layer that has been applied. Because this has been an update, we can also see previous instances that had been saved. So before was the measured, it was still passing in this case, but now it's the recommended. So all of those assets will have their history tracked as you overwrite and update your projects. Studio can also be used to search our priorities, or you can do it based on other factors such as, important sections where my, distribution cables versus feeder cables, that sort of thing. So this is where Studio can really be leveraged to help improve your grid from a optimization factor tied in with using Calc to get those detailed analysis results. And so I think that's just about at our time for this webinar. So I'm just going to jump back into our slides. So overall, the key takeaways we have from today's presentation, you can use Spida to optimize grid analysis. You can pull down existing models, bulk make changes, send those back up, use those across your company to review results depending on how you want those applied. Spida makes it really simple to review your outputs. It uses a graphical analysis. It color codes it to make it simple to review and update as required. And you can use these tools even after you've done your original engineering design for review and assessment continually throughout the status lifecycle. Quickly, before we move into questions, I'm going to put up this poll. If you could quickly answer this, and then we will move on to the question component. Okay, and before we get to questions, I lied. I will highlight that this week Bentley is having a cyber sale, so there is 20% off all Bentley software using the code cyber2022, and that does end this Friday. So if you are looking at purchasing additional licenses, they are on sale until Friday. And now I would like to open the floor up to some questions.
Thank you, Lauren. We've got a few questions here. The first one is, what training options are available?
So for training, we do have a number of different options available depending on what you're looking for in terms of involvement. So actually over COVID, we spent quite a bit of time coming up with some online training modules, which are split out into sort of a basic, how to use the user interface, and then a more advanced, which gets into some of the topics we talked today about connected designs and assemblies and how you can go about adding your own utility-specific assemblies in. So those are both available actually through the Virtuosity site as well. You can self-apply those, and you have access for I think it's about a month or so, and you can, it's self-paced, so you can go through those as you would like, and it's a generic basic online module. We do also offer instructor-led training, whether that be in person or through a web platform, where we can lead you through the basic or advanced training and answer specific questions as we go.
Great, thank you. Next question here is, what types of load scenarios are available in SpidaCalc, and can I create my own?
Yep, so SpidaCalc uses a client file, which is what we've called where we store all of the specific information related to your unique instance of SpidaCalc. So that's going to store not only your specific properties for your wood poles or concrete poles and your wires, it will also store your load cases. So this will be customizable based on, you know, different wind settings, weather temperatures, ice, that sort of thing. There are some limitations with what you can change, but all of your load factors per the major NESC Geo95 CSA codes are all editable within that view and savable to your client file.
Excellent, thank you. If my pole or anchor has an issue, will the program recommend a fix?
So It will obviously tell you first off if the anchor is failing through those analysis settings. There are a couple different ways you can go about figuring out how to fix it. One of them being the advisor tool built within SpidaCalc. So that isn't necessarily going to tell you exactly how to fix it, but it is going to allow you to run through a bulk number of scenarios about I want to change my anchor size or my anchor lead, and we can apply that and give you the output result of at this lead, this is when the anchor is going to pass, but it won't necessarily tell you that that is the best solution depending on the limitations of the field. So if you can't extend your lead because there is a sidewalk, the software isn't going to take that into consideration.
Got it. Okay. Next question here. How do I check for clearances?
So currently there is some very basic clearance functionality. We do have a profile view, which allows you to run through and visually set your weather cases for your wires and then view if those are passing or failing based on your own criteria. That being said, coming out early in the new year is going to be a version 8 release where there is going to be an included clearance module. This will also, I did see another question on terrain, so this will also address terrain. So there's going to be the ability to add in bulk terrain, whether that be from a CSV or from a service. And then you can basically in your client file define all of your clearance cases. So I want my conductor X distance above ground, or I want my conductor X distance above water, and in between primary to primary, neutral to primary, etc. That can all be pre-saved, and then it will do an automatic clearance analysis for you moving into 2023.
Excellent. Thank you. Another question here. How do I request support for the software?
So we do have a full support site that should be available with your, it would be the same login information that is used for your individual license login. So that is on the Zendesk. You can basically submit a support question to our team and they should get back to you relatively quickly depending on how complicated the scenario is.
Great, thank you. All right, got a few more here. Let's see. How do I add new items, like a new pole or conductor, to my library?
Within our client file, we have a couple different ways you can add or update your information. We have the ability for you to open a existing client file that might have that information and copy it into your current file and save that. Alternatively, you can simply open up your client file, and if you have all the information available, add in the required fields and save that to your client file.